So we have some definitions here. The normal force, when one surface presses against another, it's the force of the one surface pressing back on another. It's always going to be perpendicular to the surface. Definition of weight is the force of gravity, and it's always going to be straight down. So let's take a look at our box here. We want to draw a free body diagram. It's going to be the first thing we're going to do. So there's a force of gravity acting straight down. We'll call that Fg. Since the box is pressing against the ramp presses back up on the box. That's the normal force, but of course that will be perpendicular to the surface. We'll call that F sub n. Now, we have to break one of these into its component parts because these two forces are not lined up. So we're going to make down the ramp the x direction, which means we're going to have to break Fg into its component parts. So I'll use a different color pen. We have Fgx this way, Fgx, and we have Fgy that way. Fgy, Fgx, Fg. Question is, what is the value of Fg? Well, it's mg. Can we put in the numbers? Sure, we can. 31 times 9.81 gives us 304.1 newtons. Fgx, what is the value of Fgx? What is the value of this component right here? We're going to make a triangle out of these three component parts. We have Fg, we have Fgy, Fgx. And in earlier screencasts, we learned that this angle between Fgy and Fg is the angle of the ramp. So Fgx is the side opposite the angle. So sine of theta is equal to opposite over hypotenuse, Fgx over Fg. If I solve this equation for Fgx, Fgx is equal to Fg sine of theta. So I'll put that down here. Fg sine of theta. And if this one's the sine of theta, then that must be the cosine of theta. So Fg cosine theta. Now I can put the numbers in. 31 times 9.1 times the sine of 25 gives me the value of 128.5 newtons. And this one is 31 times 9.1 times cosine 25. Remember, Fg is mg, so that's what I'm putting in here. Mass times acceleration of gravity times cosine of 25. That gives us 275.6 newtons. What is the box's acceleration down the ramp? Alright, well, these two forces cancel each other out. This is the net force. This is the only force pulling the box down the ramp. So F equals ma. I'm going to solve that for A. A is equal to sigma F over m. But rather than put the numbers in, I'm going to do substitutions. I'll put the numbers in last. The sum of the forces is Fg sine theta. Fg sine theta is really mg sine theta divided by m. So we have an m on top and m on bottom. They cancel out. So the acceleration is really equal to g sine theta. And then if I put the numbers in, 9.81 multiplied by sine of 25 gives us 4.15 meters per second squared. That's our acceleration. So this is a ramp problem in a nutshell. There's no friction here. The only force pulling the box down the ramp is Fgx. here it is with the numbers, here it is with the variables. Again, I prefer working with the variables because I see that the mass cancels out. Acceleration does not depend upon the mass if there's no friction. And that's it. Thanks a lot.